Good morning, class. So this is the first lesson of our fourth quarter of our distance learning. Hopefully you've gone to the Google Classroom and taken a look at our assignment log for Unit 8. If you haven't, our homework for this particular homework assignment number 1 is section 10.1, page 1048, and numbers 1 through 21 odd, and 23 through 28. And our topic today, sequences. All right, so here we go. A sequence is a list of terms example. We have the list 1, 4, 9, 16, 25, 36. Then this is a sequence, and it's an infinite sequence, indicated by the ... telling us that this sequence goes on. If we were to name this sequence A sub n, well, the A sub n would give us the general rule on how this sequence is constructed. Okay. In this case, our A sub n would equal to n squared. I'm going to tell you just in a sec why n squared. Okay. So what we have here in this sequence, the 1, 4, 9, 16, 25, 36, this particular sequence, it's an infinite sequence because it goes on forever. But our domain of this sequence is the number of terms. It's the set of positive integers. So our first term is 1. Our second term is 4. Our third term is 9. Fourth term is 16. Fifth is 25. And our sixth term is 36, etc. All the way down to we're going to have an infinite number of terms. Our range are the actual values that we have here. So our rule is n squared. So this first term, a sub 1, would be 1 squared. A sub 2 would be 2 squared, which is 4. A sub 3 would be 3 squared, which is 9, and so on and so forth. So if we wanted the 9th term, even though we don't have it written here, a sub 9 would be 9 squared, or 81, because this tells us the rule for that. An infinite sequence has an infinite number of terms, goes on forever. So an infinite sequence has an infinite number of terms. There is a finite sequence has a set number of terms. Okay, so let's take a look at an example. Actually, let me get another sheet for our example. So we're going to write the first 5 terms of a sub n is equal 3n plus 4. Okay. So that means we're looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So in this case, a sub 1, everywhere we have an n, we're going to replace it with 1. A sub 1 is going to be 3 times 1 plus 4, and that's 7. A sub 2, 3 times 2 plus 4, and that's 10. A sub 3, 3 times 3 plus 4, 9 plus 4 is 13. And you may notice that you have a pattern going on here. Looks like we started at 7, then we added 3, we got 10. We added 3 more, we got 13. A sub 4 would be 3 times 4 plus 4. 12 plus 4 is 16. So once you establish the rule that's being used here, then we know that a sub 5 will be 16 plus 3, and that's going to be 19. So our first 5 terms are 7, 10, 13, 16, and 19. Let's try another example. How about a sub n is negative 1 to the nth power over 3 to the n minus 1. We're going to take a look at our first 5 terms again. All right, so in this case, again, if we're looking for the 4th term, it would be a sub 4 would be negative 1 to the 4th over 3 to the 4th minus 1. And actually this 1, this is 3 to the n minus 1. 3 to the n minus 1. So the 1 is not in the exponent. All right, so a sub 1 would be negative 1 to the first power over 3 to the first and then minus 1. So negative 1 to the first power is negative 1. 3 to the first, 3 minus 1 is 2. A sub 2, this would be negative 1 to the second power over 3 to the second power minus 1. So negative 1 to the second, whenever your exponent is even here, that's going to make that positive. Negative 1 times negative 1 is a positive 1. 3 to the second is 9. 9 minus 1 is 8. A sub 3, that's going to be negative 1 to the third power over 3 cubed minus 1. So exponent here is odd. Negative 1 times negative 1 times negative 1. It's going to give us a negative 1. 3 cubed is 27. 27 minus 1, 26. A sub 4, negative 1 to the 4th over 3 to the 4th minus 1. So that would be positive 1. 3 to the 4th is 81. 81 minus 1 is 80. And our last one, a sub 5, negative 1 to the 5th over, let's see, 3 to the 5th minus 1. 3 to the 5th would be 3 to the 4th times 3. 81 times 3, 243. Because our exponent here is odd, it'll be negative 1 over 243 minus 1 is 242. So our first 5 terms for this general rule here is going to be negative 1/2. Then we had a positive 1 over 8, negative 1 over 26, positive 1 over 80, and a negative 1 over 242. Now, one thing that you should notice here is that the signs of your terms are changing or alternating. You have negative, then positive, then negative, then positive, then negative. So these do give us alternating signs. I want you to kind of remember that vocabulary word because that's going to be really important, especially in calculus, but later on as well. Okay. So let's move on to our next topic. Recursion formula. You should remember a bit about this from Algebra 1, but if you don't, no big deal. So, the recursion formula can be used to define a sequence. Okay, it gives the nth term of a sequence as a function of the previous term. So in order to find the 6th term, I'm going to use the 5th term in some sort of function. In order to find the 19th term, I will need to know the value of the 18th term, etc. So that's kind of the recursion process there. So let me give you an example. Let's say a sub 1 is set at 5. And a sub n is equal 3 times a sub n minus 1 plus 2. And this is for all n greater than or equal to 2. Now there are limitations to this. We're given a sub 1 is 5. Let's say we wanted to find a sub 6. Well, a sub 6 will be 3 times a sub 6 minus 1 plus 2, which is 3 times a sub 5 plus 2. Well, we don't know what a sub 5 is, so there's no way for us to determine what a sub 6 is. What this formula allows us to do is if we start with a sub 1, we can find a sub 2, then a sub 3, then a sub 4, a sub 5, a sub 6. So we have to go in that order. Okay, so let's go ahead and try this. First 4 terms. So a sub 1 is 5, then a sub 2, everywhere you have an n, you're going to replace it with a 2. So that's going to be 3 times a sub 2 minus 1. So 3 times a sub 1, and then plus 2, which is 3 times, well, a sub 1 is 5, plus 2. 15 plus 2 is 17. So now we have a sub 2 is 17. Now that we know a sub 2, we can find a sub 3. A sub 3 will be 3 times a sub 3 minus 1, so a sub 2 plus 2. 3 times 17 plus 2. 3 times 17 is that 21 carried as 51 plus 2, so that's 53. And a sub 4, 3 times a sub 3 plus 2. So that would be 3 times 53 plus 2. It's 9. 159 plus 2, 161. So our first 4 terms with this particular sequence would be 5, 17, 53, and 161. All right, let's go ahead and move on to our final topic for today, which is factorial notation. Okay. Okay, so factorial notation is the product, and remember when we say products, we're talking about multiply, of consecutive positive integers that often occur in sequences. So if n is a positive integer, then n with the exclamation mark, and this is read as n factorial, is the product of all positive integers from n down to 1. So it's the product of all of the positive integers from n down to 1. Now, we're going to start off with a definition. So 0 factorial, so n is a positive integer. Remember, 0 is neither positive or negative, but we do have a definition for 0 factorial. Okay, so 0 factorial is equal to 1. Okay, so that's our definition. 0 factorial is equal to 1. 1 factorial is equal to 1. 2 factorial is equal to 2 times 1. So we start at 2, and then we go down to 1. So 2 times 1, so that's 2. 3 factorial is 3 times 2 times 1. So we start at 3, and then we go down to 1. So that's 6. 4 factorial, 4 times 3 times 2 times 1. Remember that 3 times 2 times 1 is 6. So 4 times 6 is 24. 5 factorial. 5 times 4 times 3 times 2 times 1. Start at 5. Take the products going down to 1. 24 times 5 is 120. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. So 120 times 6. 6 times 12 is 72, 720. Okay, then 7 factorial and so on. 7 times 6 times 5 times 4 times 3 times 2 times 1, etc. So the numbers grow, and they grow pretty fast. 7 factorial is 5,040 because it would be 720 times 7. Okay, so these numbers, they grow and they grow fast. All right, so what about n factorial? So let's say we have some n factorial. So our general rule would be n. Then it would be multiplied times 1 less than n. So that's n minus 1. So it's 7, then we multiplied it by 6. Then our next factor is going to be 2 less than 7, or 2 less than n. So n minus 2. Then n minus 3 times, till you get down to 1. 3 times 2 times 1. Okay. What if we started with n plus 2 factorial? Well, our first factor would be n plus 2. Then we would be 1 less than that. So that would be n plus 2 minus 1, which would be n plus 1. Then our next factor would be 1 less than that, n plus 1 minus 1. N. Then our next factor would be 1 less than that, n minus 1, n minus 2, and then 3 times 2 times 1. Okay. So what's really important for us, especially when you guys get to calculus, is being able to manipulate these factorials both explicitly and implicitly as well. All right, so a couple of things we need to keep in mind with the factorials. Okay. So have to be careful with grouping. All right, so 2 times 3 factorial. Is that the same as 2 times 3 factorial? Well, if we think of PEMDAS, this factorial will be performed before the multiplication. So 2 times 3 factorial is the same thing as 2 times, then 3 times 2 times 1, which is 2 times 6, and that's 12. Whereas 2 times 3 factorial, that would be, we do the parentheses first, 2 times 3, so that would be 6 factorial, and 6 factorial is, I believe, 720. Okay, so you got to be really careful with the grouping there. And then also, is 3 factorial times 3 factorial, is that equal to 3 times 3 factorial? What do you think? Well, here's what we know. We know that 3 factorial is 6. So if we perform the factorial first, so that would be 6 times 6, which is 36. Whereas here, we would do the parentheses first. 3 times 3 is 9. And 9 factorial would be 9 times 8 times 7 times 6. So we know there's no way that that's equal to 36. It's actually equal to 362,880. So no, this property does not hold. Okay. All right, how do we simplify factorials? So let's say we had 18 factorial divided by 15 factorial. Okay. Well, 18 factorial divided by 15 factorial, well, 18 factorial is 18 times 17, 16 times 15, 14 times 13 times 12 times 11 times, and then finally we're going to get 3 times 2 times 1 divided by 15 factorial, 15 times 14 times 13 times 12 times 11 times, and then finally we're going to get 3 times 2 times 1. So what it looks like is the entirety of the denominator will simplify out to 1, because starting from this point forward, it's 15, 14 times 13 times 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, which is exactly what this is. So all of this and all of that are going to simplify to 1. So our final answer would be 18 times 17 times 16. Well, we don't want to write this out, because what if I gave you 130 factorial divided by 126 factorial? We're not going to write all of those out. So what do you notice with this? This 18 factorial is 18 times 17 times 16, but once we get to this point here, the rest of this, 15 times 14 times 13, all of the rest of that is 15 factorial. So 18 factorial over 15 factorial, 18 times 17 times 16 times 15 factorial, divided by 15 factorial. And there's our answer. Okay. So with our factorials, they can be represented multiple ways. Example, 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. But 5 times 4 times 3 times 2 times 1 is 5 factorial. So we could write 6 factorial as 6 times 5 factorial. Or 6 factorial is equal to, if we go 6 times 5, well, 4 times 3 times 2 times 1, that's 4 factorial. Or 6 factorial, if we go 6 times 5 times 4, well, this remaining part here, 3 times 2 times 1, is 3 factorial. All of these are going to give you the exact same value of 720. So you may need to manipulate the factorials by writing them in such a way that you're able to simplify. All right, enough of the factorials. Let's take a look at how we're going to use factorials in sequences. Okay. So here we go. Let's use factorials to find terms of a sequence. Okay, so here, let's say we have a sub n, and that's going to equal to 2 to the n over n minus 1 factorial. And we're going to find the first 4 terms. All right, so a sub 1, well, everywhere you have an n, you're going to replace it with 1. So that's going to be 2 to the first over n minus 1, so that'll be 1 minus 1 factorial. So it'll be 2 over 0 factorial. And then we know that our definition at 0 factorial is 1. So 2 over 1 is 2. So that's our first term. A sub 2 would be 2 to the second power over 2 minus 1 factorial. 2 to the second power is 4. 2 minus 1 is 1 factorial. 4 divided by 1 factorial is just 4. A sub 3, well, that's going to be 2 to the third over 3 minus 1 factorial. 2 to the third is 8. 3 minus 1 is 2 over 2 factorial. So that's 8 over 2, and that one's 4. So a sub 2 and a sub 3 are both 4. A sub 4 would give us 2 to the fourth divided by 4 minus 1 factorial. So that's 2 to the fourth is 16. 4 minus 1 is 3 factorial. So that's 16 over 6. And when we simplify that, 2 goes into 16 8 times, 2 goes into 6 3 times. So our first 4 terms are 2, 4, 4, and 8 over 3. Okay, couple more examples and then we are all set. Okay, so let's simplify the following. So let's say a is equal 14 factorial over 2 factorial times 12 factorial. So we already showed before that 2 factorial times 12 factorial is not 24 factorial. Okay, so 14 factorial we can write as 14 times 13 times 12 factorial over 2 factorial times 12 factorial. 12 factorial divided by 12 factorial is 1. So now we have 14 times 13 over 2 factorial. 2 factorial is 2 times 1. And we're all set. 2 goes into itself 1 time. 2 goes into 14 7. 7 times 13 is 91. So that would be our solution. Next example, let's say b is n factorial over n minus 1 factorial. Okay, how do we simplify this one? Alright, when I get a problem like this when I like to think about numbers. So let's say I have some n factorial on top and then I have n minus 1 factorial on the bottom. So let's say we let n equal 8. Then plugging numbers in there, we would get 8 factorial over 7 factorial. What would that look like? Okay, so think about that. Let's go ahead and do it symbolically. N factorial would be n times 1 less than n, so n minus 1, times 2 less than n minus 2, n minus 3, times 3 times 2 times 1. Okay, n minus 1 factorial would be n minus 1 times, and now we're going to do 1 less than that. So that would be n minus 1 minus 1, which is n minus 2, and then minus another one, n minus 3 times 3 times 2 times 1. So in this case, the n minus 1, all of that reduced to 1, and our final answer is just n. Now, if we were to perform this with a number, so let n equal 8, then we would have gotten 8 factorial over 8 minus 1 factorial over 7 factorial, and that would have been 8 times 7 factorial over 7 factorial, and our answer would have just been 8. It doesn't matter what positive integer you let n equal to, whatever n is equal to, your final answer will be that value. Okay. All right, ladies and gentlemen, this concludes our lesson for the first assignment from Unit 8, fourth quarter, our distance learning. I will have tutoring during our class time tomorrow, which is Thursday, for period 3, and for period 4, it'll be Friday for you. Okay? But if you have any questions, please don't hesitate to email me. And looking forward to meeting with you guys again. Take care.